Hello and welcome to the second part of our basic training on the remote SIM provisioning. My name is Olga Hitler. I'm a senior technical consultant at Comprion. Let's dive in. So on the agenda, you can see on the slides what was the first 4 topics. So we talked about the eSIM. So why do we have this concept? We talked about the applied RSP technologies, the trends and deployments on the market. We talked about the 2 different solutions defined by GSMA, the M2M, machine-to-machine, and the consumer devices one. And we introduced the concept of the profiles, the profile switching. But today we have a different agenda, so we will go to the high-level architecture of the M2M ecosystem. We'll talk about the roles and players in the M2M ecosystem, and also about the security aspects, such as keys, certificates, and algorithms. But first of all, let's try to remember what were the main topics from the first part. Let's have a look back. So about the definition, so take a look on the definition of the USSC, the 2 GSMA solutions, and the profiles. Okay, if you remember, we had these 5 questions, which were kind of a summary. So what are the 2 main challenges for the traditional SIM? So I think we talked about the challenge of the vulnerability and the lack of space. And another challenge was the logical one, the challenge of switching of the operator. GSMA definition, so we'll talk about this later. The advantages of the EOSSC. Please don't miss this, so you can take a look on the first part of the training. The constraints of industrial and consumer IoT. So there are 2 different deployments of the in the IoT market, so and especially of the USSC. And the constraints are, yes, the advantages of the specific situation of this. This has an influence on the structure of the M2M ecosystem or on the consumer devices ecosystem. Yes, I hope you have your own examples. Okay, now you can see on the slides the definition of the EOSSC in terms of GSMA. This is an EOSSC which is not easily accessible or replaceable. It's not intended to be removed or replaced in the terminal and enables the secure changing of the subscriptions. This means that remote SIM provisioning allows remote switching between operators. And this solves the first issue, so the logical one, so the access issue. But please be reminded that the EOSSC is explicitly defined not to be a soft SIM. It's still a piece of hardware, meaning that we have having the USSC functions together with the RSP functionality. This is what we call the EOSSC from the logic. And ETSI defined the specific form factors, like so-called M2M form factors, to be used for soldered USSCs. You can see on the screen an example of such USSC. And this solves the vulnerability issue. To summarize on this, so we had these questions. What are the 2 GSMA solutions for EOSSC deployment? I hope you know this. This is the M2M, machine-to-machine, and the consumer devices one. The main difference between M2M and consumer devices, common features, and the difference between M2M and consumer device from the profile deployment perspective. Okay, what is a profile? And what are the different profile types? Also your own examples. Okay, for the 2 RSP solutions, we have this machine-to-machine. And the main difference was the direction of control. So in the M2M world, so the idea is that, that the control comes from the backend infrastructure. So the backend infrastructure is in control of which profile is deployed. And in the consumer devices world, so the end user decides which operator to take. For the profiles, okay, there is also a difference from the deployment perspective of the profiles. In the consumer devices world, you don't need a profile to be pre-installed because you can use another technology, so you don't have to use the network to download the profile. So you can use Wi-Fi, Bluetooth, or whatever, which technology you like, so to download the profile. In the M2M world, it's a bit different. In the M2M world, so you need the network connection to download the profile. Otherwise, it doesn't work. Okay, this is the main difference from the deployment perspective of the profiles. Okay, and the profiles. An EUSCC can hold more than one profile. It depends on the storage capability. So the profile can be downloaded, then it needs to be enabled. But only one profile can be currently enabled at a time. Okay, this was kind of summary of, so what we had in this first part of the training. So very short summary. Yes, but it's important to remember, because when we go now into details of the architecture, so it will help you to understand the architecture way better. So actually, as you can see also the common features. So we mentioned last time, so that the common features were, some components are quite similar from the idea of the deployment. For example, we have subscription managers. And yes, we're using the systems are using, the ecosystems is using the public key infrastructure, for example. So this is one of the similarities. But it's still the case that this cannot be deployed together. So for example, if you have a background system implementing the M2M part, so you cannot use the EUSCC implementing a consumer part together with the system. It doesn't work. Okay, I hope you're ready. Let's dive into the architecture. Okay, we'll talk about the actors and roles, the general architecture, and the procedures in the M2M world. Okay, now you can see the players, the main components of the M2M architecture. So let's start with the EUSCC. I think it's better. So the EUSCC, so this is the main component. So then for the communication purposes, we have the subscription manager, the SMSR, subscription manager for secure routing. We have the SMDP, subscription manager for data preparation. For the EUSCC, we have the EUSCC manufacturer, or EUM. We have the CI for the certificate issuer, so to issue the certificates to the different components of the system. For sure, we have the operator. On the first versions, it was called the MNO, mobile network operator, but so operator is a more general term. In the latest version, so we have also this M2M SP, so M2M service provider, and device. First version didn't contain the device because actually it was out of scope of this M2M specifications. The idea was that the device is just the kind of a transmitter or transmission between the services in the background and the EUSCC. It was not considered, so it was not relevant. So it has no own role in the M2M architecture. Okay, now you can see the diagram together with the interfaces. Don't be afraid. So I know there's a lot of interfaces, but actually for me, the first time, so it was helpful to print it out and have it in front of me on my desk, just that I could see all of the time the interfaces. Otherwise, it's difficult to remember all of this. Yes, at least for me, it was difficult. Yes, but while using this, you will have no problem with the definition of this interface or this interface, and for sure not with the components. So let's start. So we'll talk about first about the components, and then afterwards we'll talk about the interfaces. Okay, let's start with the first component, the EUSCC. You can see the interfaces coming to this, and so the connections actually. The EUSCC has the connection. Yes, for sure, it's produced by the EUSCC manufacturer, but this is out of scope. And yes, the second main part, so this is the ES5 interface to the SMSR subscription manager, and the ES8, so to the subscription manager for data preparation. And also, so we have this interface to the operator, so to have the regular OTA communication, over-the-air communication. Yes, and kind of an interface which is partially defined is the interface to the device now. For sure you remember the definition of the EUSCC, which is not intended to be removed or replaced and enables the secure changing of profiles. It's good to remember, so what is the EUSCC itself? So the internal high-level architecture of EUSCC is similar for the GSMA M2M and consumer devices. So we'll have a container for profiles. So this is on a very high level. So I don't have a picture for this. This is part of the advanced training. So we have container inside of it and the specific architecture to where you have the several parts separated as usual with the concept of the security domains. If you are familiar with the concept of security domains defined by global platform, then you are already good to go. So on the good side. One of the security domains is so-called the EUSSC Controlling Authority Security Domain, or ECASD. You can see this abbreviation in many places, and especially when it comes to the certificates, because this is a security domain. It holds all of the keys and certificates, or manages the certificates. And also another important part is the ESD. So this is a concept defined by GSMA, by Global Platform. It's a security domain, and the R coming from GSMA now is the root security domain. So these are the security domains installed and personalized. The profiles are provisioned and based on the security framework defined in the Global Platform card specifications. So sometimes if you don't find in the GSMA specifications some specific definitions, so it's helpful to know the Global Platform specification and actually also the ETSI specifications as well. But we'll talk about this in the last part of the training. The EUM, or the EUSSC manufacturer, in the world of, in the ecosystem of the EUSSC, also in the M2M world, so the only relevant interface is the ES1 interface to the subscription manager for secure routing. Okay, the other connections, so they are out of scope, but they are actually existing. So the connection to the CI and to the SMDP. Okay, what is the role of the EUM? For sure, to deliver the EUSSCs. The EUM is responsible for initial cryptographic configuration and security architecture of the EUSSC. Okay, so it means that the EUM predefines a specific configuration. We'll see when we'll talk about the keys later on today. So that some keys have to be pre-personalized inside of the EUSSC, and this is the responsibility of the EUM. And also to issue certificates. Yes. Specifically, the EUM issues the EUSSC certificate to allow the EUSSC authentication and the proof of certification to other entities, and to allow the authenticated key establishment between the SMDP, subscription manager for data preparation, and an EUSSC. Okay, subscription manager. Okay, we have two different types. This one is the subscription manager for data preparation. And you can see the connections, yes, for the connection to the EUSSC, the connection to the SMSR, and you can see the connection to the operator. And so it means that there is a link between those entities, and there is a communication paths or functions defined for these interfaces. Okay. The important role of the data preparation subscription manager is kind of a first encapsulation of the profile. So the security architecture defines the communication in the way as soon as the operator has a profile in whatever form. So either completed or generic. Yes, so then it's delivered to the SMDP. And then it's kind of, the security means that we have kind of two envelopes. The first envelope, so we put the profile inside of this first envelope, so first security level. And this is the data preparation part, so from the security point of view, but not only. So actually, so as the word says, so it's the role is to prepare the data. And then the second part would be by the secure router. So it would be the second envelope. Okay, it means, so for this, since we're talking about security, this is why I'm saying this, means that every SMDP shall be certified according to the GSMA agreed certification scheme. Yes, and based on the SMSR identification and address, the SMDP is able to establish a new link to the identified SMSR during any procedure requiring this step. So it means that the SMDP connects to the SMSR for the next step of delivering the profile to the EOCC. The SMDP is responsible for the key set establishment, profile download, and for installation. Yes, download and installation are protected by profile manager credentials shared between the SMDP and the specific security domain inside of the EOCC, the so-called ISDP, Issue Security Domain for the profile. It's a specific kind of a container inside of the profile. The SMDP can be triggered by the operator to execute or initiate specific functions on this ES2 interface. The SMDP can establish a link between SMDP and SMSR for secure routing and can address the USSC through a secure channel. Okay, just a short comment on the secure channels. So the secure channels we are using here are defined basically by global platform. These are the SCP-03 and 03T. And this secure channel will be established between the SMDP and the ISDP. Yes, let's go to the SMSR. Now you can see from the many interfaces that this is a router scan, really, so it's connected to almost everything. And yes, it has many interfaces. Subscription manager for secure routing. Again, since we're talking about the security, so that every SMSR shall be certified according to a GSMA agreed certification scheme. So this is quite important, otherwise we have a security lag. The SMSR is in charge of the management of the targeted EOCC management, meaning enabling or disabling, things like this. And SMSR is free to select the most relevant protocol according to the EOCC and the device capabilities, and the platform or profile management operations to be executed. Meaning, so there are different protocols to be used, and the SMS also to be used for the transmission of data. And this is actually the SMSR selects a way how to use this. Meaning, by exclusively handling of the OTA communications. So since everything is working over the air, so we have the over-the-air communications, and so the channels which are used, are SMS, which are defined, SMS, HTTPS, or CATTP, but the CATTP is actually not used in the protocols. Not used and not tested in the real world. Yes, and the idea of this, the usage of this OTA communications is the EOCC remote provisioning and management. Okay, for this purpose, the SMSR verifies the SMDP requests if they are acceptable. Okay, I hope you have an understanding of this now. So it's kind of a, router manager inside, so real manager of the routing, yes, maybe this way. And so it's selecting the protocols, SMS or HTTPS. So it also depends, so depending on the command being sent. So the command may be quite short, so like enabling command, or the download command is quite long. So, and the correct choosing of the correct protocol is quite important for the performance reasons. The next part is the certificate issue. Yes, this is the security relevant part when we will talk about the roles, who is playing this role in the real world. So it will be the GSMA. We'll talk about this later. Yes. And the role of the certificate issuer is to issue certificates. Yes, certificate issuer issues cryptographic certificates for remote provisioning, SIM provisioning entities. Those like EUM, SMDP, and SMSR, and acts as a trusted third party for the purpose of authentication of the entities in the ecosystem. The certificate issuer communicates with the server and the EUM through interfaces that are out of scope of the GSMA. This is why you saw this ... lines of the actual GSMA or SGP technical specifications. The certificate issuer acts as a trusted third party for the purpose of authenticating the entities of the system. A trust anchor, meaning the root CI certificates, including the root CI certificates includes the CI public key, is pre-stored or pre-shared between the EUSSC and subscription managers for authentication of the profile download. Okay, so we'll come back to this once again. So, but just to understand, so this is one of the reasons. No, it's not not the main reason. No, but it's one of the reasons. So why some systems cannot work together. So the reason may be so that the trust anchor is different inside of the background system. So meaning in the server side and inside of the EUSSC. We have different trust anchors on this parts, these components. So so the communication will not work. So because of the security problems. Okay, operator. So actually the role of the operator remains the same towards the EUSSC. So the common OTA commands are remaining, but there are new rules and yes, new interfaces to connect. So the connection to the SMDP and the SMSR. Okay, who is the operator? Operator is the entity providing access capability and communication services to its customers through a mobile network infrastructure. An operator hosts a platform for remote management of EUSSCs and the content of enabled operator profiles on EUSSCs. Okay, sure, for sure. So the operator needs a specific platform to manage all these profiles. Yeah, and for sure the operator defines or specifies a profile structure. So because this is under full control of the operator. Yes, so in general, so the structure of the profile, so the interoperable structure is defined by the former SIM Alliance group, but trusted security alliance. So yes, actually, so normally, so everyone still speaks about the SIM Alliance currently because the name switch was done just recently. Yes, but there are still some components inside of the profile which is under responsibility of the operator. So it's all under responsibility of the operator, but inside of the profile, so the content of this profile, so this belongs to the operator, and it's operator's choice which parts of the profile to fill with data. It's all defined by the operator. Yes, and the operator uses ES6 functions to address the EUSSC through a secure channel. The operator can request an action of an SMDP through the ES2 interface, where he can provide the identification of the SMSR in charge of the management of the EUSSC targeted by the function. Yes, and the operator can use ES4 to control, also ES4 interface to control profile functions on the SMSR. M2M SP. M2M service provider. Yes, this is actually a new role defined in the latest version, so starting from the version 4 of the specifications. You can see it doesn't have too many connections. This role has been defined as an optional instance to take over management functions on behalf of the operator. For example, so an M2M service provider can get granted the rights to provide the profiles on the EUSSC relying on an operator, execute certain platform management commands on a profile based on prior profile lifecycle management authorization from the operator. So there is still the profile lifecycle management authorization needed so to use these commands, to execute these commands. For example, enable profiles via connected SMSR, disable profiles via connected SMSR, and delete profiles. And yes, ISDPs, actually the profile containers. Okay, device. So why do we have device and why is only partially defined? Yes, actually, before the version 4 of the specification, GSMA had the position that device can be everything. So and they so therefore it's out of scope of the M2M specifications, because the device can be a wind turbine, or the device can be a car or whatever. So yes, but actually coming to the cars, especially due to the development on the market, we had this definition of the emergency calls. And the emergency call defined for the in the automotive area, so emergency calls for the cars in case of the accident, was one of the reasons to define some specific commands to to execute this kind of emergency enabling of a profile. Okay, in terms of the GSMA, devices, equipment into which an EUSSC communication module are inserted during assembly. Okay, the examples are very different. Okay, with the introduction of the device, local administration, so for example, enable, disable of emergency profiles and test profiles on the EUSSC without involvement of an SMSR or SMDP has become possible. Okay, you probably ask yourself, what is an emergency profile and why I didn't mention this inside of the first part of the training. Actually, emergency profile is the same as a operational profile with a specific indicator of a profile to be allowed to be used for the local administration. Okay, to execute the local administration tasks, the ESX interface is used. Okay, so we have this specific local administration task. So we talked about in general, we talked about different components. I hope you can remember all of the names because it's quite important, especially if you will take a look into the advanced parts of the training. If you don't, so if it might be quite helpful for you if you take a look into the glossary inside of the handouts that you have. And yes, in the next step, we'll talk about the interfaces and procedures. Okay, here we go. Okay, so now you see the architecture. So now you're already familiar with the components. Let's take a look first on the interfaces. The blue lines in our picture are the off-card interfaces. The ES2, ES3, ES4, ES1, and ES7 interfaces. Actually, so these are the interfaces to the off-card entities. So all of the server parts or entities that are not on the card. And the communications is happening all inside of the network or ecosystem. Yes, here we have the EUSSC interfaces. Basically, for the communication with the entities which are on the server part or the background part, and including the interface which is only partially defined, so the ESX interface. Okay, the interfaces to the CI and the interfaces to the EUM or interface between the operator and the M2M service provider, they are not defined in the now you can see already the SGPO2. This is the main specification used, technical specification to be used for definition of the M2M architecture and the whole ecosystem. Yes, and it's not a part of it. This is the subject actually of the agreements between those entities. Let's go to the procedures. Okay, we have the M2M procedures. So the main procedure, or the first one, is the procedure between the operator and EUSSC. So initiated by the operator, but there are many steps in between. And finally, actually, yes, for sure, the profile download can be initiated by the operator on behalf of as a result of some contracts. Actually, yes, and the initiation happens remotely through different steps of the connections. We'll take a look on this a little bit later. Yes, and the profile download installation contains some sub-steps. First step is the so-called ISTP creation on the EUSSC. First of all, we create kind of a container inside of the EUSSC. And the second step, the personalization of the ISTP with the first key set is called the key establishment procedure. So the first key set has to be established. And then finally, after the establishment of the key set, the profile itself can be downloaded and installed on the EUSSC. Profile download installation, actually it's also coming from the separation coming from global platform from the background. The next procedure initiated from the operator to the SMSR is the profile enabling. It makes the applications and files within the profile visible and selectable. So it can optionally go from operator via SMDP to the SMSR. Same way, but other way around. So from the operator to SMSR goes with a, optional also via SMDP. The profile disabling makes the applications and files within the profile invisible and non-selectable. Finally, the profile deletion, operator to SMSR. Optional again via SMDP. So it's used to delete the target ISDP, the profile container, with its related profile data and applications from the EUSCC. Master delete. Okay, the initiated can be different one. Initiates the deletion of an orphan profile. Hope you remember what an orphan profile is. So without the fallback attribute set. So as now we have two terms from the first part of the training. I hope you remember what it is. Actually, so we are trying to, so with this master delete, we're trying to collect all of the dead bodies of the profiles inside of the ERCC and to erase them. Yes, and it doesn't matter which profile policy rules. You remember the profile is governed by policy rules. So in this case, it doesn't matter. So the profile will be deleted. And actually it's become an orphan profile because of the policy rules and the specific situation. SMSR change. This is actually a procedure between two SMSR. So this is a process where the transfer of the ERCC information set, or ICE or ES, for a specific ERCC from one SMSR to another. So if you have specific data of an SMSR stored there, so then you have to move it to another one. So in this procedure, let the other SMSR know, okay, there is specific set of, so I have the specific set of the ERCCs. They are under my control. So please, you can, I'm moving this to you because I'm not longer in control of this. Yes, and for this, the key set establishment is needed. Yes, but with the ISDR, so not the key set establishment used for the profile download with the ISDP, but it's the so-called the second, what I was talking about, the second envelope, when you establish a specific key set for the between the secure router and the URCC. Yes, this is this procedure of moving this data and the key set establishment for the next step of the enveloping of the profile. So this is called the SMSR change or SMSR swap. Okay, EUSCC registration is used by the EUM to register an EUSCC information set representing an EUSCC to the SMSR. First of all, so when in the regular way, so if the information EUSCC information set needs to be registered by the SMSR, otherwise the SMSR doesn't know that this EUSCC is existing. Policy update. So we have two types of policies. The policy update 1 is performed by the operator and EUSCC using the ES6 interface, and the operator uses its OTA keys. Policy 2 update is performed from the operator to the SMSR, and the operator sends policy 2 directly to the SMSR through the SMDP to attach them as a metadata to a profile. Yes, you can see, so since the policy 1 communication is to the EUSCC, that policy 1 is one on the EUSCC and the policy 2 is on the server side. Connectivity parameter updates. Okay, there are always some parameters for the connectivity to establish connectivity. So, and as this one will be updated between the operator and the EUSCC. Yes, and this initiated by the operator on the ES6 interface or by the SMDP using the SCP, so specific cryptographic protocol on the ES8 interface, SCP-03. Yes, notifications. So there are always notifications to inform the server components or backend components. So what is happening, what is ongoing on the EUSCC, that their control can be kept. And here we have the default notification procedure or different notification procedures. It's coming from the EUSCC to the SMSR using SMS or HTTPS. Fallback activation. You remember, so what I explained to you also by the fallback profile, the profile with a fallback attribute. Actually, this is the according procedure, specific procedure. So there's this showing that the profile is, this procedure will be activated in case the currently enabled profile loses network connectivity. If there is no connection to the network, so the USSC has always to be connected, then the USSC disables the currently enabled profile and enable a profile with a fallback attribute set. So we had all of the procedures, so now named. Now you can again have a short drink or whatever. So and we'll take a look inside of the procedures. I will continue. So with some examples what it means. From the profile download, so you can see, so this is very simplified view. So we have the components involved on this profile download. So we have the operator, SMDP, SMSR, so everything goes over the network, and then it goes to the M2M device with the USSC inside. First of all, so we download the download profile command will be sent. And then the SMDP requests the USSC information set from the SMSR. And after receiving this, it creates the specific container on the profile, on the USSC for the profile. With the create ESTP command on the ES3 interface. It goes to the USSC, will be forwarded to the ESSC by the SMSR. The response is coming. And then afterwards, the key set establishment procedure will be performed. You can see there's two envelopes because we have two interfaces and two types of security. And then the last steps are download and initiation. And afterwards, we have the note that the profile download is completed. The response to the download profile command coming to the operator. This is very simplified. You can see the different interfaces. This is what I explained with the different types of envelopes. So we have different interface security features used here. So first of all, the SCP-80 and SCP-81, so SMS HTTPS protocols, basically. And then the really cryptographic security, so actually the others cryptographic as well, secure channel protocols. SCP-03 and SCP-03T protocols to be used between, so for the communication to the USSC. So the USSC finally receives this kind of envelope with two security protocols inside, around the profile. Yes, next step will be the enable profile procedure. What is the unique features? So we talked last time about the common features between M2M and consumer devices solution. Yes, in M2M everything is remotely managed, requiring no human interaction. In the M2M solution, the USSC connects to the SMSR using BIRA independent protocol BIP, where the underlying BIRA being either SMS, TCP/IP, or CATTP. CATTP is not really used in the real world, but it's defined. BIRA choice and termination can have an impact on the performance of the download. Device adaptation is not required for the M2M solution. The M2M solution includes the SMSR as an entity that is not required in the consumer device architecture. The SMSR acts as a gateway from the operator and SMDP through to the USSC. The SMSR holds a database of all the USSCs under its control and the key sets used to manage it. The USSC information set, remember? Okay, this was unique for M2M. Yes, and actually, so it means a group of deployed USSCs is managed by a single SMSR. And when there is a change of the operator, there might also be the need to move the management of the group of USSCs to another SMSR. So it depends on the contracts and on the logic behind, business logic behind. This SMSR swap, so it means this is what we are talking about, SMSR change or SMSR swap. So this SMSR change includes transferring the group of EUSCs using a defined SMSR swap procedure. The negotiation of new cryptographic keys with each EUSCs of that group needs to be handled by the new SMSR. Okay, this was hard stuff. Take a look on this again. So take your time. I have some questions for you to remember. So to prove your knowledge. Okay, what are the components of the M2M ecosystem? What are the off-card interfaces? Just to keep in mind which interfaces are going to the EUSC, which are going to the off-card entities. So please try to remember or to print out the page with the architecture. What are the EUSC interfaces? Which steps are required for the profile download procedure? 3 steps. What is specific for M2M solution? What do you remember from all of this? Okay, now we have a break, so you can go through the slides once again. You can stop, you can continue. So we'll be back soon. So I suggest you to have a break because the next topic will be the roles and the security as well. Thank you. Bye.